Okay, Bismillahirrahmanirrahim. Let's start our class. Today, we will discuss very important protective device, that is the circuit breaker. So, circuit breaker is a device that can open or close a high voltage circuit in a fraction of a second. Okay, so as the circuit breaker is used for the protection in case of the fault. So when a fault occur, it open its contacts and keeping away the fault current to flow through the circuit. Okay, but in the normal conditions, it allow the current so the contacts remain closed. Okay, so when the fault occur and the contacts of the circuit breaker are open, so in this case the arcing is occurred. So for this purpose we have to make some arrangement for pinching the arc. Otherwise, if the arc is not pinched, so there may be a serious problem. Uh, for example, despite of opening uh, the contacts, it remained closed and it remained welded inside. So from the outer side, we will observe that it is open, but rather it will be closed. So the arcing phenomena may deceive the viewers and operators by this way. So arcing should be pinched. So for that purpose, different insulating media is used. Uh, so we will discuss these arcing, pinching mechanism and different arcing media that is used for the pinching of arc in the upcoming slides. Okay, so the opening and closing is achieved by the separable contacts of the circuit breaker. Okay, by separation of the contacts, the closing and the opening of the circuit is performed. So there are two contacts in circuit breaker. The one is fixed and the other is movable. Okay, so when the movable contact begin to separate, the circuit breaker begins interrupting the current. Okay, by this way it is going to interrupt the current by moving the movable contact. Okay, so arcing phenomena occur, as I have already told you, that arcing phenomena is very dangerous and it should be avoided. uh, so let's discuss how to avoid this arcing phenomena. Okay, okay, the arc plasma must be cooled and extinguished in a systematic way so that the gap between the contacts can again withstand the voltage in the circuit. Okay, there must be some mechanism that the volt the voltage must not restrike after opening the contacts. Okay, so this type of the voltage is called restriking voltage, and this restriking voltage must be avoided by once the arc is quenched, so restriking voltage will not be occurred by any way. Okay, so different mechanism is used. The one is the uh, uh, horn gap. Okay, so the horn gap actually provides the quenching of the arc. Okay, so first it separated the arc outside the contacts, and then it provides a high resistive path by the air gap. So by this way the arc is extinguished. Okay, this is one of the methods. Some other methods are the cutting of the arc by just like by this type of mechanism. Okay, for example, this is the iron gap. Okay, and the other method is to provide this type of ups and downs, crust and trough structure. So this is actually, you can say, the texturing, the textured structure. By this mechanism, the arc is ups and down in these crust and trough. So the arc be uh, will be cut out in fractions. So by this way, it will be it will be get rid. We will get rid of this arc. Okay, and this fraction arc is of no importance. Okay, there is nothing to danger from this fraction arc. So this is one of the methods of pinching the arc. Okay, the study of this phenomena is very composite but has enormous importance while selecting the operating characteristic of circuit breaker. Okay, so the types of the circuit breaker is actually categorized on the basis of the media used for arc pinching. So from this point, you can imagine the importance of the arc phenomenon. Okay, because this types of the circuit breaker is categorized on the basis of the media used for arc pinching. Okay, so the separation of switching contacts of any circuit breaker leads to the formation of the gas and metal vapor between them in its current carrying conductor. Okay, once the contacts of the circuit breaker is open in case of the fault, so a metal vapors and the gases is formed. Okay, so even when no potential is applied across the electrode, the gas conducts and sets up a small current due to natural ionization. These vapors, metal vapors, actually are the plasma, and you know plasma is the conductive part. This is actually the plasma, and plasma is the ionized particles, and it is actually the conductor, having the conductive properties. So uh, these metal vapors and these ionized plasma actually causes the leakage of current, and this leakage of current is dangerous. So when an electric potential is applied across the two electrodes, the charges carry gain mobility, and their motion depend on the applied electric field intensity. So once the electric potential is applied, these plasma actually gain the mobility, and stronger is the electric potential applied, stronger will be the mobility these charge carriers will gain. Okay, so this is dangerous. So when the moving charge collide with the electrodes, uh, ions move towards the cathode and the electrode moves towards anode. Okay, these are the motion of the ions. The cathodes are the cation. The cation are actually uh, having the positive ion, so it will move towards the cathode, which is of negative charge plate, and the anions are negatively charged bodies, so it will move towards the anode, which is positively charged electrode. Okay, so they disperse their charges and a current flows between the electrodes. So this process of current conduction in a gaseous medium is due to the ionization process such as photoelectric or thermionic emission, and remains continuous till a potential is applied. So we have already discussed this phenomena in the Townsend theory, that once we have the electric potential and some ionized particles are present in the gap, so these ionized particles have the ability to ionize other neutral particles by the collision. Okay, and we have all also discussed the condition that if the kinetic energy of these moving charges is greater than the ionization potential of the neutral gas particles, so then what will happen? We will have the ionization of these neutral particles. So it will be more dangerous because uh, these ionized particles will then acts as this the source of ionization for the next neutral particles. So uh, that is why uh, this type of ionization should be avoided. Okay. Okay. There is actually a curve OP which shows the linear relation between the current and the voltage in the initial stage when a small value of applied voltage. Okay, one this is VI characteristic curve. Okay, when we have the voltage, so the current will move between the electrodes, and we will have a linear curve. The discharge current through the medium is proportional to the applied potential until an equilibrium is reached, where the production of the charge carriers uh, is equal to the charge carrier received by the electrode. Okay, so this linear relation actually occurs till the equilibrium is reached, where the production of the charge carrier is equal to the charge carrier received by the electrode. Okay, so when the ionized particles are received by the electrodes are equal to the charge carrier newly produced. So till this equilibrium point, we will have a linear relationship. Okay, and the discharge current will be flowing. Okay, so this is actually you can see it is a Townsend a curve. Again, we have already discussed this in high voltage. So this is a linear. Then we have an equilibrium condition, and we have discussed this equilibrium condition that there is a after this a role of positive ions is emerged. Uh, it means when we have the positive ions that are striking the cathode. So the positive ions are actually the protons, which are the uh, heavy mass particles. So greater is the mass, greater we will have the momentum, and when these protons will strike the cathode with high momentum, so what will happen? It will knock out more electrons from the cathode particle itself. So the secondary ionization is actually occurred. Okay, so by this way we will have a saturation of the current. So in the first part OP, we will have the primary ionization. This is the equilibrium condition, and PQ are actually the avalanche condition, and this is caused by the secondary ionization. Okay, and the role of positive ions occur over this region. So if the electrical potential across the electrode increases to a high level, so ionization occurs freely and free positive charges gain a high velocity. I have already discussed this point that this is actually the role of the positive ions, the protons, and it gains the high velocity. Okay, hence they strike the cathode with enough force to knock out a number of free electrons from that maintain their discharge. Okay, this is actually the reason for the avalanche caused by the positive ions. So such discharge remain self-sustained because it does not require any external excitation. Okay, the process rises exponentially and the current continues to increase between two electrodes even when the applied voltage remains the constant. Okay, so actually it the exponential rise is occurred. As we have discussed in the Townsend theory, that we will have I naught uh, e raised to the power alpha t. Okay, so it means exponentially rise occur in the current. Even we have the constant voltage. The voltage that forces such occur high current density million of charges through a gas medium. This is called actually the breakdown voltage. Okay, we will have a breakdown voltage. At this voltage, the complete uh, breakdown of the gas insulator is occurred. Okay, QR gives the indication of such a high current at mm, this breakdown voltage. Okay, QR curve is the avalanche region, and a flood of electrons flowing at this voltage. Okay, VB. Okay, so the gases between the electrode no more remain insulator, but provide a current conducting path. Okay, as we have a flood of ionized particles, so now this the space between the electrodes is no more an insulator. Okay, rather this insulator is converted to the plasma, that is the ionized particles, and we call it the conductive path. Okay, owing to this, a continuous arc is produced between the electrodes, which are surrounded by a hot ionized gases. And this phenomena is applicable for both AC and DC voltages across the electrodes. Okay, no matter if we have the DC voltage or the AC voltage, this phenomena can occur in both of AC and DC. Okay, now the quenching or the extinction of the high current is done externally. So it is very important to decide the VB and insulating medium to quench the arc while designing the circuit breaker. So for all of this ionization, we have to make some arrangement that how to quench or extinction or extend the high current. Okay, so for that purpose we have to decide an insulating medium to arc to quench these arc. uh, Actually we have the insulating, what the insulating media will do, it actually freezes the ionized particles. So once the ionized particles is freezed, so it will not collide with the other neutral particle, and no collision will be occur, so no more ionization will be occur. So we have to make some arrangement so that the ionized particles, the already ionized particles should be remain freezed. Okay, and it may not play the role of for the source of targeting the neutral atom. Okay, the discharge occur in AC and DC circuit is due to the high the breakdown voltage due to the self inductance of the time of contact separation. Okay, so the electric arc has a low voltage drop which induces large value of the current. Okay, so the factors responsible for the formation of arc, the voltage across the electrode. Okay, greater is the voltage across applied across the electrode, greater is the chances of the arc phenomenon. Okay, and its variation with time. Their nature means we have what type of structure we are using for the electrodes. Okay, then it means the material used for the electrodes, the shape means spherical electrodes are used, or rod type electrodes are used, or some other uh, type of electrodes are also introduced that are called the Rogowski profile electrodes. Okay, so these type of electrodes are good for uh, the uniform um, field. Okay, and the separation of the electrodes. Okay, so Okay, so the arc is also responsible for, also depend on the nature, separation, or and the shape of the electrodes. The nature and the pressure of the medium. Okay, what type of nature means, whether it is solid or so solid cannot be used in a circuit breakers. The vacuum or the blast, air blast medium, or you can use the SF6, or also some oils, uh, ester, ether, etc. Okay, and the pressure of the medium, the presence of the external ionizing and deionizing agent. Okay, greater the external ionizing or deionizing ionizing agent, greater will be the chance of arcing. Okay, and it is conversely related that greater we have the deionizing agent, so lower will be the chance of arcing. The nature, the shape, and the position of the circuit breaker in which electrodes are located. So it is also depend on these parameters as well. Okay, the R characteristic is a curve between the instantaneous voltage across the electrode and the corresponding current through the R. Okay, so the rate at which the current changes its value in the upper range has no such effects on the degrees of the R voltage. This is due to the nonlinear resistance characteristics of the arc and the sluggish rate at which the heat content of the nearby area of the arc is established the new heat content. Okay, it means we have to draw the characteristic curve for the circuit breaker for the instantaneous voltage and the corresponding arc current. Okay, so uh, if we have the non-linear resistance characteristic of the arc, so we will get the non-linear characteristic curve. Okay, the voltage drop across the electrode depend on the collection of the positive and negative charges in front of the cathode and anode respectively, and it also depend on the electrode materials. The voltage drop across the main arc column mainly depend on the type of the cases surrounding it, the gas pressure, and the magnitude of the arc current and the length of the column. Okay. So the main arc column depend on these factors. Okay. Okay. Now these are the anode and cathode. Okay, and this is the arc column, the arc length. Okay, so as we have discussed in this, that the arc column depend on the type of the case surrounding it, the gas pressure, and the magnitude of the current, arc current, and the length of the column. Okay, the temperature at the middle of the arc column is of the order of 5,000 to 8,000 degrees C. This huge amount of the heat should be avoided. Okay, and the temperature at which at the periphery of the arc rod is of the order of 2000 to 3000. Okay, at the middle we have 5000 to 8000, and at the periphery of the arc rod we have 2000 to 3000. The voltage gradient across the main arc column is uniformly distributed across the length of the arc. Okay, the voltage gradient is uniformly distributed throughout the length of arc. The theory of the arc quenching in the AC circuits. So the quenching of the arc, okay, the quenching of the arc in the AC circuit requires a mechanism that converts the conducting path across this conducts of the circuit breaker into non-conducting path. Okay, as I have already told you that there some arrangement must be done in order to convert the ionized particle into deionized particles. Okay, so for this purpose, the AC current passes zero twice each cycle. Okay, for each cycle we have two zero crossing. The one is this and the other is this or this. Okay, so we have two zero. So at this the conducting current is zero. So we have to make some arrangement over these points. So these are actually the positive points for us to control the arc quenching. Okay, hence arc quenching is performed at the natural current zero in AC circuits. Okay. Okay, this is actually the wave shape of an arc current and arc voltage. Okay, so E arc and I arc. Okay, so the dotted actually shows the E, the voltage, and this solid line shows uh, the current. Okay, so you can see that we have uh, the two zero crossing points. Okay, there are two major peak voltage alterations that occur at the time of high current zero crossing. When an AC current crosses its zero, the effect of the deionization and the cooling of the arc is measured, which causes the arc voltage to rise. Okay, so at this point, the voltage is raised, ER and EP. Okay, ER and EP, rising voltage. Okay, so this occurs at zero crossing point. This is the pre-arcing time, this is the arcing time, and this is the recovery voltage. Okay, so when the fault start. Okay, so the voltage, okay, the arc voltage become just like this. Okay, at the zero crossing we have the peak voltage. Okay, so after the arcing, uh, if uh, so this restriking voltage will be just like this. Okay, transient restriking voltage, final arc extension. Okay, waveform of the voltage in the current at which the time at the time of the arc extension. Okay, so the the arc is now recovered. Sorry, the voltage is now recovered. Okay, this is the short circuit time period. Okay, okay, now what is restriking voltage? This one, restriking voltage. Okay, the restriking voltage at the time of the zero crossing of the arc current, the arc tries to get quenched. If the deionization process does not achieve enough dielectric strength, the arc restrike and the voltage at this instant is known as restriking voltage. Okay, so we must use the dielectric medium having enough dielectric strength to deionize the arc quenching phenomena. Okay, and if the dielectric strength of the medium is not good. Okay, so then there is a chance of restriking voltage. Okay, okay, now arc voltage, the voltage drop across the arc rod because of its resistive nature is known as arc voltage. Owing to its resistive nature, it is in phase with the current arc current. Okay, so both the arc current and the arc voltage are in phase. Okay, this is the arc voltage, this one. Okay, this is the arc peak voltage peaks. Okay, the transient restriking voltage. Okay, transient restriking voltage, TRV. It is defined as the high frequency restriking voltage that appears across the contacts of circuit breaker just after the arc extension. Okay, here the R is extinguished, so now this type of transient restriking voltage occurs. The TRV, the transient restriking voltage developed across the open contact of the circuit breaker is given by Vc is equal to E maximum into 1 minus cos omega t, where omega is the natural frequency. Okay, this is equal to 1 over LC under the root, and it is of the order of 1 to 10 kilohertz, depending on the system condition and the parameters that are L and C. Okay, so Fn is equal to natural frequency is equal to 1 over 2 pi LC under the root. Okay, the rate of rise of restriking voltage, RRRV. The higher the frequency of the transient voltage, the sharper will be the slope of its first voltage rise from 0 to peak. Okay, the slope of this steepest tangent to the restriking voltage curve is defined as the rate of rise of restriking voltage. Okay, so it totally depends on the frequency of the transient voltage. Okay, so if it is sharper, so we will have the steeper slope for the restriking voltage curve. These are some equations. RRRV is measured by dividing the maximum amplitude of the first peak to the time required to reach the first peak. Okay, so RRRV is equal to d by dt of Vc. Okay, rate of change of uh, uh, voltage. Okay, and RRRV is the rate of change of E maximum, replacing this value. Okay, Vc, the arc quenching voltage, arc voltage. Okay, so replacing this value in this equation, so we'll get E maximum into 1 minus cos phi t. Okay, so by taking the derivative, the derivative of E maximum, and this is constant E maximum, one is 0, and cos is minus cos is the cos is minus sine, so minus minus plus sine omega t into d by dt of omega t, so we will get omega. Okay, the maximum RRV occurs at omega t equal to pi by 2, because the sine is maximum at 90 degrees, so omega will be pi by 2, means 90 degrees, so we will get a maximum RRV value. Okay, thus at t is equal to pi by 2 LC whole square root, the value of RRE will be maximum. Okay, so E maximum into omega. Okay, if the value of sine omega t is if the value of omega t is pi by 2. Okay, the recovery voltage, the power frequencies, steady state voltage appearing across the conducts of the circuit breaker after the final arc extinction is known as recovery voltage. Okay, so after the final arc quenching, once the voltage is appeared to its normal condition, so this is called the uh, what, the recovery. Okay, before the this is actually the steady state condition. Before the steady state we have the transient condition. Okay, so this TRV is the transient state, and now this recovery voltage is actually the steady state condition for the voltage. Okay, after the arc is quenched. So this was all about the circuit breaker. In this, we have discussed the principle of the circuit breaker, and then we have discussed uh, the arcing phenomena and the factors responsible for the arcing phenomena. Okay, and then we have discussed the reason for the arcing, why the arcing occurs. Okay, so uh, we have discussed that the arcing actually occurs by the ionization of the particle, the gaseous particle present between the the contacts of the electrodes of circuit breaker. Okay, So for this purpose, we have to quench these arc, and we have also discussed some terminologies for the arc quenching in circuit breakers. These terms are the restriking voltage, okay, and then the arc voltage and the transient restriking voltage, and then the rate of rise of restriking voltage, and the final was the recovery voltage. Okay, so I hope you will understand all these terms and the whole phenomena for the arc quenching and the mechanism of the arc quenching in circuit breakers. Okay, and the fundamentals of the circuit breaker, that what are the protective, uh, how the circuit. In the next class, we will discuss about the fuses and some types of the circuit breakers, which are categorized according to the arc quenching. Okay, so that was all about for the today's class, and thank you.